today I'm going to talk about the very important topic which is work, power, and energy. So let's try to understand it with the help of a diagram. So it will be more clear. For a while, consider that there is a surface, a plane surface which has no resistance, or we can say that the resistance is negligible, right? So let's take a box and place it over here. So let's take. Okay, so this is basically a box which is placed on the surface here. For example, this is a box M placed here. Just for a while, consider it, right? So this is a box M, and for example, a boy. I'm only just drawing the hands over here. Maybe it's not perfect since I'm trying it to draw it in a right way. So this is hands, something like this. So yeah, just consider it, right? Pulling the box in this direction. So tension is acting here, but since the force is applied, which means this boy is pulling the box with the help of this thread toward himself, but this box the displacement take place in the x direction y. It is something like this. The displacement is taking place in the x direction, and after a while, this box displays to this position, in this position. This become at this position. Why? What? Which force is responsible, or which component is responsible for displacing a body in the x direction? We know that the if we just saw it, if we just focus, or we just see, we can focus, or we can identify that there are two components acting here, something like this. So let's draw it here so that it will be more clear, something like this. Yeah, this. For example, now this is a thread which the boy is pulling toward himself. So this is component making the angle theta toward between it. So this is x component, and this is y component. Both two forces are other components are acting x component. Since only this component is responsible for displacing the body toward its direction, while y component is playing no role here, which means that there is no place of the y component for displacing the body toward its direction. We know that when a force is applied, or for example, the force is applied on this box and it displays in the direction of the force. So work done is equals to force into displacement. Since the work is the dot product. Now, what is mean by dot product? Which means that when two vector quantities multiplied and the answer is scalar, this is known as dot product. And whenever we remove this dot product, we get a function which is cos theta, which is a function of the dot product. So let's see it. For example, vector A multiplied by vector B will prove it why this box is displacing in the direction. Vector A dot vector B is equals to magnitude of A yet magnitude of B, and yes, cos theta. So this is basically something that we know, that this is basically proof that cross product of two quantities, which means dot product of two vector quantities, give us scalar, which is work. Work is a scalar in nature, right? So let's state that why body is not displacing in that direction. So now we are aware of the formula of displacement. Now we are aware of formula. So let's see it, why it's just happening here when the body is not displacing in that direction. So let's see it. Okay, we are now aware of the formula of the displacement, not displacement but the work done. So work done is equals to force into force. Which component? X component responsible for the force displacing the body in the x direction. So which is F cos theta, F cos theta into displacement, which I'm representing with S. So this force is x component responsible for displacing the body toward its direction. But if I say it now for a while, consider that why we are considering the y direction component. So I can say that F sine theta, okay, F sine theta dot displacement, and then cos theta, because we are considering the essence y component, but cos theta is important because it's just in formula. So something like this as cos theta. As we can see here, the angle is 90 degree. Displacement takes place in direction where the component is acting upon this direction. So angle between them is 90 degree. So there will be something like this: W is equals to same term and cos 90. We are aware of that cos 90 is equals to 0. So cos 90 is equals to 0. So complete work done will be equal to 0. That's why this is basically a reason that we don't consider the component of the y direction. We only consider the component of the x direction, because we are aware of that. We consider the component of the y direction, so the work done will be 0. And here we doing the work done on body by constant force. We are only considering the constant force here while dealing with this formula. If we're dealing with the body which by constant force, the formula will be by constant force, which means neither the magnitude of the force neither displacement of the body changes. It's equal, right? It does not vary, right, by constant force. So we can apply this formula, which is W is equals to F dot B, or F multiply FD cos theta. That this is basically a formula that we can apply if we are dealing with such stuff or body which has a constant force and constant direction. Now, what I mean by constant force and constant direction, which means that neither its magnitude nor its direction changes, which is in the equal direction. So we know that the x component is responsible for displacing the body in the x direction. This is responsible for displacing the body in the x direction. So let's remove it and let's discuss the cases here in the video as well, so that we can write up this topic. So let's just erase it. Okay, it's erased. Let's move a little up. So let's do it. Now cases. Let me write it cases here. And before writing cases, we can say that the word identification of the, or we can say that it is important to tell that for which force we are finding the. Okay, so